Tree diagrams are a very useful device. They come in handy when you're trying to organize your thoughts, particularly in situations where you have more than one event and the events occur in sequence. Here's an example. Angus is a contestant on a quiz show and he's asked two questions. He has a 30% chance of answering the first question correctly. And if he does, he has a 20% chance of answering the second question correctly. If he answers the first question incorrectly, then he's going to have a 60% chance of answering the second question correctly. Now you can see that these two probabilities right here are conditional probabilities. They depend on what happens on the first question. And you can see, since these are different, that what happens on the second question is not independent of what happens on the first. Now, in situations like this, where you're dealing with conditional probabilities in sequence, tree diagrams are very useful. So let's draw a tree diagram for this situation. First thing you do is you start with your first question, okay, or your first random situation. And you're going to draw, here we have question 1. We're going to draw a branch coming out of question 1 right here for each possible outcome. In this situation, there are only two possible outcomes. We have getting the first question right and getting the first question wrong. Okay, the probability of getting the first question right is 30%, that's 0.3, and the probability of getting the second question, or first question wrong is 70%, or 0.7. So it's the probability of getting the first question right, and this is the probability of getting the first question wrong. Okay? And what we're going to do is we're going to fill in outcomes and their probabilities on each branch. Okay? If you had more than two possible outcomes, you would have more than two branches. You'd have a branch for every possible outcome in the situation. Okay, now the second question starts here, and there are two possibilities on the second question: getting it correct or getting it incorrect. And that means we're going to have two branches coming off of each of these nodes. And they will indicate on each branch what that branch represents. This branch right here represents getting the second question right, and this one represents getting the second question wrong. Down here we also have the possibility of getting the second question right or the second question wrong. Now the probabilities we're going to put in here and here are going to depend on what happened on the first question. Okay, this probability right here is the 20% chance of answering the second question right if this contestant Angus answered the first question correctly. So this probability right here is going to be 0.2, and that is a conditional probability. It's the probability of getting the second question right given that they got the first question right. Okay? Now the complement of that is getting the second question wrong, and there's a 0.8 chance, 0.8 or 80% chance of that happening if the first question was answered correctly. That's also conditional probability. It's the probability of getting the second question wrong given that they got the first question right. Down here we're going to have some probabilities. The probability of getting the second question right if the first question was answered incorrectly is going to be 0.6. I guess the people who run the game show don't want too many people going away unhappy, so they want them to at least have a chance of success on some question. This is a conditional probability. It's the probability that they get the second question right, given that they got the first question wrong. And then there's a 0.4 chance that they'll answer the second question incorrectly. In this circumstance, that's a conditional probability of getting the second question wrong, given that they got the first question wrong. So all four of these probabilities are conditional on what happened over here. Now if you look at each of these nodes, the probabilities coming off of each node have to add up to 1. These two are complementary, they have to add up to 1, and they do. These two probabilities have to add up to 1, and they do, and so do these two. Okay, so you can check your work when you're making these diagrams, make sure these probabilities add up to 1 coming off of each node, regardless of how many possible outcomes or branches you have coming off of that node. Now, we can summarize all this information. There are 4 possible outcomes, and each outcome has a probability. And we'll make a little chart out of those. So this outcome right here is getting the first question right and the second question right. So it's R1 and R2. This outcome is getting the first question right and the second question wrong. So that'd be R1 and W2. This outcome coming along this branch is W1, getting the first question wrong and getting the second question right. And this last outcome here is getting both questions wrong. And we can find the probabilities of these 4 outcomes by just multiplying along the branches. To find this probability, we multiply this number times that number. 0.3 times 0.2 is 0.06. To get this probability, this outcome, multiply along the branch. 0.3 times 0.8 is 0.24. Now you notice these two add up to 0.3, as they should. Okay, now to find this, the probability of this outcome, multiply along the branch. 0.7 times 0.6 is 0.42, and then 0.7 times 0.4 would be 0.28. The probability of getting both questions wrong. These two probabilities have to add up to 0.7, and they do. And all 4 probabilities, of course, have to add up to 1, and they do. So when you're drawing these tree diagrams, you have lots of opportunities to check your work and make sure that everything's working out correctly. Okay, so draw off of each node a branch for each possible outcome. Put the probability of each of those outcomes on the branch. Those probabilities coming off of each node should add up to 1, as those do, as those do, and as those do. Define the probabilities of these compound events here. Multiply along each path from the first node all the way to the end. And since there were 4 possible paths, we have 4 possible probabilities to go with these 4 possible outcomes.